Welcome to The Explainer. Today we're going to tackle a classic Hollywood trope and break down the actual mechanics of the silent symphony of the vacuum. Let's just dive right into the physics of why our universe is so beautifully, eerily quiet.
Section 1. The Hollywood Space Myth. Let's talk about explosions in space.
You know the scene, right? Massive spaceships battling it out, lasers flashing everywhere, and those thunderous bass-heavy explosions literally rattling your theater seat. It's an incredible sensory experience. We completely expect it at this point. But think about it. If you were an actual astronaut floating right there in a spacesuit watching that exact event unfold, would you actually hear those epic blasts? The answer, and you might have guessed it, is a resounding absolute no. All of that brilliant cinematic sound design, yeah, it's purely for our entertainment down here on Earth. But let's dig into the actual physics of why space robs us of those awesome sound effects.
Section 2. How sound actually travels and why it absolutely needs a medium.
Okay, so for sound to even exist, it physically requires a medium to travel through. We're talking air, water, or solid objects. Basically, think of sound like a wave of energy trying to push through a really crowded room. It needs physical particles bumping into one another, literally knocking shoulder to shoulder to pass that motion along. Because we are constantly surrounded by densely packed particles here on Earth, they carry sound waves super easily.
Section 3. The silent vacuum. What happens when space lacks those particles?
To understand why space totally breaks our earthly rules of sound, we have to remember what a vacuum actually is. It's simply an area with very, very few particles. When you blast off and leave Earth's atmosphere, you are stripped of that cozy little blanket of air molecules. And because there are incredibly few particles floating around out there in the near-total vacuum of space, well, mechanical sound waves simply have nothing to move through. There are literally no microscopic messengers to carry the noise to your ears.
So picture this. Two giant spaceships are engaged in this intense orbital duel. They collide, right? Exploding right next to each other in a massive blinding fireball. If you were floating just a few hundred feet away, how much of that destruction would you actually hear? Zero. Zero sound. You wouldn't hear a single boom. It would be a breathtaking, unbelievable visual spectacle of light and fire, but it would be completely, totally, eerily silent.
Moving to Section 4, the radio exception. So, how exactly do astronauts talk to each other?
This brings up a really crucial contrast between two totally different types of waves, sound waves and radio waves. While sound waves are mechanical, and like we said, absolutely need physical particles to travel, radio waves are electromagnetic. Their absolute superpower is that they don't need a physical medium at all. They can propagate straight through the empty vacuum of space without a hitch. That is exactly how mission control can hear an astronaut's voice loud and clear, even when they are floating in the ultimate silence.
Section 5. Rethinking Sci-Fi Movies. The battle of fiction versus reality.
It really all boils down to this one simple fact. In real space, it is completely silent. So the next time you sit down to watch a massive blockbuster filled with roaring starfighters and booming lasers, you can just kind of smile, knowing the actual physics. Real space doesn't roar. It's a beautifully quiet vacuum where sound simply cannot exist.
It really makes you view your favorite films differently, doesn't it? Understanding the true nature of a vacuum kind of transforms how we imagine the whole universe. And honestly, it leaves us with a fascinating final thought for you to ponder today. What other movie myths are hiding in the silent vacuum of space? I mean, if Hollywood completely invented the sound, what other cinematic tropes are totally scientifically impossible? Keep that curiosity alive, always question the science behind the screen, and I'll catch you in the next explainer.